This game learned how to play itself. For a little while now, I have been wanting to make a project that involved three things I like: machine learning, mechatronic, and game development. This is how I came up with the idea of a video game that would learn how to play itself using a gamepad. For the game and machine learning part, I decided to use Unity and its ML Agents toolkit. Those two combined make reinforcement learning relatively easy. Right from the start, I took the decision to keep things very simple and decided to build upon one of the examples included with the Unity ML Agents toolkit, the ball balancing exercise. This means the mechatronic parts of this project would be very easy to develop using just an Arduino and a couple of servos. I started by designing the mechanical parts. Unfortunately, I haven't recorded any of my design process, but here you can see the assembly. Once everything assembled, it was time to create a simple program for the Arduino that would move the joystick across its motion range. With this, I also created a very simple Unity scene that would help me roughly calibrate everything. The next step was to handle the communication between the game and the Arduino. This was easily done using serial communication, and just to make sure everything was working properly, I added a few lines of code to get the robot to replicate the position of the left stick onto the right one. The position of the left stick simulates the output of the future neural network controlling the game. At this point, it was time to start building the game. As mentioned earlier, I took example on the ball balancing exercise. The goal of this game is to balance a ball on a platform. I added an extra bit of challenge by placing a target on this platform that the ball needs to get as close as possible to. If the ball falls off the platform or the game lasts for too long, it will be reset. I thought a little bit of color wouldn't hurt, so I designed a few textures to try to make things a bit nicer. I will let you judge, but I don't think I really achieved my goal here. Alright, so now it was time to start training. I won't go into too much details on reinforcement learning because this is a very complex subject, but here is a very simplified explanation on what's going to happen here. We will take our robot, also called an agent. This agent is going to observe the game. Here it will look at the position and speed of the ball, how close it is from its target, and the angle of the platform. Then, based on his observation, it will take an action, basically move the joystick. It will either get a reward or a punishment depending on the outcome of this action. If the ball falls, it will be punished by being given a negative score or rewarded with a positive score if the ball is still on the platform. The closer the ball is to the target, the bigger the score will be. This cycle will be repeated many times, and as a result, the agent should learn what action to take to get the highest score. So I started the first round of training. At the beginning, the agent clearly has no idea what to do. After about 600 games, it somehow starts to understand how to keep the ball on the platform. After another 500 games, it manages to keep the ball closer to the target. By the end of the training, which took about 6 hours, the model was able to balance the ball sort of close to the target while still being able to catch the fastest balls. But the robot was still very twitchy and I didn't really like it. I knew I could get more out of it, so I decided to retrain with extra reward for smoothness. A few hours later, the result was a little bit better, but not quite as good as I was hoping. I went through a few more rounds of training, trying various reward and punishment systems without much improvement. At this point, I already wasted nearly 2 days. So it was time to put a new strategy in place. I decided to split the training in half. For the first half of the training, I wouldn't be using the hardware at all. This allowed me to train multiple agents at once, which means they could all learn collectively. And this also allowed me to train new reward and punishment system, as well as new network parameters such as a number of hidden layers, number of neurons, and so on. And all that in a matter of minutes instead of hours. In the second half, I would reintroduce the hardware to the digitally pre-trained model. After a few trials, I found a system that got good results, so it was time to reintroduce the hardware into the training. I was hoping the pre-trained model would handle the hardware fairly well. Unfortunately, it wasn't the case. To be very honest, it looks like it's probably more of an issue with my code more than anything else, since it seems to throw the ball out of the platform in one particular diagonal direction. The good news was that the model was actually actuating the joystick in a much smoother way now. After trying to find out what the problem was, I was unable to find any solution, so I tried to resume the training in the hope that the model would correct whatever issue was there. I quickly realized that it would take a lot of time to sort out, so I decided to restart the training from scratch with hardware. I knew my network parameters were good as well as my reward system. I was much more confident that this round of training would be successful. Out of nowhere, my computer decided that it was too hard to work, so it had to rest for a few minutes, and once cooled down it was back into action. After training, this is what I ended up with. It is still a little bit twitchier than the fully digitally trained model, and I believe this is because the network is actually trying to compensate for the imperfection in the hardware. All in all, it was a very fun project. I hope I will be able to do more of this type of work in the future, and I hope you really enjoyed it as well. So thanks for watching, and bye bye.